Assalamu alaikum. We are going to solve another problem on array. This is a question number 2 for lab number 8. Write a program in assembly language using MIPS instruction set that reads 12 integer numbers, in fact, from the user and store them into an array called int array. Print the numbers in the array that are divisible by both 5 and 7 and find the sum of those numbers. So you have actually, in fact, 3 different tasks here. One task is reading 12 integer number from user, and you have to store them into an array called int array, and as well as you have to find out the numbers that are both divisible by 5 and 7. You have to print those numbers. For example, you can see sample input output here. Total 12 numbers are entered. Numbers that are divisible by both 5 and 7. You can see out of these numbers only 35, which is both divisible by 5 and 7, and 70 is also divisible by 5 and 7. So it is printing those numbers which are divisible by 5 and 7 separated by space, and then it also print the sum of these two numbers which are divisible by both 5 and 7. So we have basically 3 different tasks. One task is reading the number using a loop, 12 integer number you have to read from the user. And while you are reading the number, actually within the same loop, what you can do, you can find out for each individual array element whether the number is divisible by 5 and 7. If it is divisible by 5 and 7, that's the question, where should we keep it? You can keep it in a separate array variable, or you can print the numbers. But if you want to print the numbers at that time, it is not possible um, because you are still taking the integer number, reading the integer number. In that case, what you can do, you can have a two separate loop. One loop which will read 12 integer number and store the number into an integer array. The other loop you will employ where you will go through with each element of the array which is in the main memory, and then you will find out whether the array element is divisible by 5 and 7. If it is divisible by 5 and 7, you just display that number separated by space. And then after the second loop, you just need to add in the second loop, actually, whenever you will find a number which is divisible by 5 and 7, you print it and you add it to a register. So basically what you have to do, you have to use 2 different loops. One loop will be using for reading 12 integer number from the user and store it into the array called int array. Then second loop, you have to go through with each element of the array one by one using another loop, and there you have to check each integer number whether that is divisible by 5 and 7 or not. If it is divisible by 5 and 7 both, in that case you just display the number and add the number into a register, which will be actually your sum register. And after the end of the second loop, you just display the sum. So let's start our problem. Let's solve the problem. A bit of time. Yeah, it's here. So first, new, and save the file. So lab 8, problem 2, save. So we'll have dot data and we have an input message dot ASCII, and we have the input message is enter 12 integer number. So we'll just copy and paste it there. Copy and paste it there. Output message 1, output message 1, dot ASCII Z. We have two output messages. In fact, one is numbers that are divisible by 5 and 7 are, this is first output message, should be within a double quote, and second output message is sum equal to. So that is also ASCII Z, and that is sum equal to. Now the second one should be displayed with /n so that it can go to the next line. But in between, when you are printing the numbers which are divisible by 5 and 7, if any number, if we get more than one number, it should be separated by space. So you should declare a variable called space dot ASCII Z, ASCII Z, ASCII Z, and in between there is a space. Now, before actually printing, before declaring all these input message and output message, you need to declare your array variable. As you know, our array variable name should be int array. In the problem we specify, and as per the problem, actually, you can see that we have to read 12 integer number. Since we have to read 12 integer number and store 12 integer number, so 12 multiplied by 4, so 48 bytes are required for storing our array. So we need to declare space and then specify the total number of bytes that are required for storing this integer array. So in this case, we need 48 bytes for storing this integer array. So far so good. We can go to the text. Text basically, first thing first, we need to print the input message 1, enter 12 integer number. This is the input that we need to print. So we are going to print that input message 1. So for printing any string, you need to use the interrupt number 4, interrupt number 4. Then you need to put, or you need to put the starting address of your input message in A0 register. So our input message, starting address of input message should go to the A0 register, and then syscall, which will actually call the interrupt. Now here, here we are printing the input message 1, and after printing the input message 1, our job is to read 12 integer number. And in order to read 12 integer number, you know that we need a loop variable, so we can declare a loop variable t0, which is initialized to 0. So this is our loop variable. This is our loop variable. And we need actually our starting address of the array. As you know that, as I discussed with this one, actually assembler, whenever you declare this array variable int array, assembler needs actually in the main memory total 48 bytes, which is free. Now, if that 48 bytes starts from here, for example, this is an example, it can start from here, it might start from here, it might start from here, it might start from here. So it will just check 48 bytes consecutive, 48 bytes, and then it will start from there. So it's not necessarily, it must be always 0012. It can start from 0048. And if you get 48 bytes from starting from 0048, assembler will allocate the memory space there. So just for our example, I am showing you that 0012 is the starting address from where you will store total 12 integer number. So what we need to do, we need to keep our starting address of the array. Since we have already declared the array variable, so memory has already been allocated for that array variable, and the starting address is also been assigned, but the values are not stored there because we have not yet read any value and we have not stored any value in the array. So we'll do that one later on, but just check here what we are going to do. We need the starting address LA $S0, comma array variable name is integer array. So starting address of this array variable will be stored in S0. In our example, it will be 0012. So getting the starting address of each array, and then we need to copy it to some other register. In this case, we want to copy it in S1 register. So S0 register value should be added with register 0, and then it will store in S1. So starting address being copied, so to $S1. So both S0 and S1 are pointing to the same memory location. Both S0 and S1 are pointing to the starting address of the array. Now what we are going to do, we'll write a loop which will read one by one integer number from the keyboard and store it in this array. So we'll go through with that one. First, uh, for loop read, for reading the integer number. So our loop variable is t0. We can write branch greater or equal. If it is greater or equal t0, if it is greater or equal to 12, then we should exit the for loop. Exit the for loop for read, for loop for read. So we'll exit that one. Whenever t0 is less than 12, we'll continue the loop. But if t0 is greater or equal to 12, then it will come out from the loop. So we are writing here the label exit for loop. This is the level exit for loop. Uh, but if t0 is less than 12, we need to continue the loop. The first thing that we need to do in the loop is reading an integer number from the keyboard. Now, in order to read an integer number from the keyboard, we need the interrupt number 5, and then syscall will read an integer number from user. So this one is reading an integer number from user, and after reading the integer number, our job is that we need to store that number into the memory location that is inside the array. In order to do that, we need to use sw from v0, because when you read a number, integer number from the keyboard, this number will be stored in v0 by the operating system. So from v0, you need to store it into the memory location. Which memory location? The memory location that is pointed by S1. Remember, both S0 and S1, both S0 and S1 is now pointing to starting address of the array. So now S1 is also pointing to the first element of the array. Then it will point to the next element of the array. Then it will point to the next element of the array. Then it will point to the next element of the array in each iteration. So, but at the beginning, it is pointing to the same memory location S0 and S1. So whatever the memory location pointed by S1 will get this value. So as the first value, as per our input, the first value is going to be entered by the user. For example, in this sample input output, the first value that will be entered by the user is 10. So 10 will be stored there. So after writing this statement, the value 10 will be stored in the first element of the array. After writing the first element of the array, now our job is to increment our loop variable. So that if we don't increment our loop variable, you know that it will be infinite loop. So we are going to increment the value of t0 by 1, value of t0 by 1, and as well as after incrementing the value of t0 by 1, now we have to actually get the displacement. Now in order to get the displacement, we can use the variable t2, register t2, and t0 should be multiplied by 4, should be multiplied by 4 to get the displacement. So t0, the current index of t0 is 1. 1 will be multiplied by 4. Result will be stored in t2, and now we have to update the value of S1. So S1 is now pointing to the first element of the array. Now S1 should be the value of S0, which is the base address of your array, starting address of your array. That should be added with your displacement. Now displacement is basically calculated, you calculated in T2. Displacement is basically the index number multiplied by 4. So if your index number is now 1 multiplied by 4 is 4, so that is your displacement. 4 and base address value will be added together, and the result will be stored in S1. So our T2 will be added together so that we can get the new value of S1. So what will happen after this iteration, the S1 is now pointing here, it's not pointing anymore to 0012, it is now pointing to the next element. So after updating the value of S1, we should now jump to the beginning of the for loop. We should jump to the beginning of the for loop. If we jump to the beginning of the for loop, what will happen? T0 is still 1, which is less than 12. So we'll enter the loop, we'll read a new number from the user, and that number is stored in V0. That will be stored in the memory location that is pointed by S1. And you know now the memory location is pointed by S1 is 0016. So the value that will be entered by the user, say for example, value that is entered by the user is 14. So 14 will be stored in this memory location. So this is 14. And what will happen after doing that? You have to increment your index variable. So index variable will now become 2, and that 2 will be multiplied by 4. So your displacement is 8, that is stored in T2. So displacement 8 plus your base register value, which is 0012. So 0012 plus 8 is 0020, which will be the new value of S1. So S1 will now point to 0020. So you can see that S1 will now point here, and that is the new value of S1. So this loop will continue, and finally, actually, it will read all the 12 integer number, So then 20, 28 will be stored there. 20, 20, then it will store 28, so it's no longer here, it will now become here. Then 30, 35, so 30 will be stored here, 30 will be stored here, so S0 is no longer there. Then 40 and 42, so 40 and 42, so now S0 is no longer there, S0 will be now here. So A0 will be here, 42 has been saved. Now 45 and 49. So 45 and 49, 49. So S1 will now become here. Then 50 and 70. So 50 and 70. In this way, all the numbers, it will come here. Okay, after finishing the loop, the S1 is now pointing here, but S0 is still pointing to the beginning of the loop, but S1 is now pointing to after the end of the loop. We have done our first task, reading 12 integer number, and the data has been stored in the computer memory, so in the int array. So we go back to our code. We have done the first part. Let's put some storing the number into an array and implementing the loop variable. So we need one more loop. As we know that another loop should also go through it 12 times. And in that loop, we are not going to read the number, rather we'll load the number from the array and check whether the number is divisible by both 5 and 7. If it is divisible by both 5 and 7, then we'll print that number. Otherwise, we'll not print that number, and we'll iterate through all the numbers in the array. And whenever we'll get a number that is divisible by 5 and 7, that will be displayed, separated by space, and finally we'll show the sum. Now, sum is the third part. So, but now we need to do one more loop to print all the values which are divisible by 5 and 7. So first thing first, we need to display this output message 1. So before we start another loop, just print a output message 1. So dollar $v0, 4 LA dollar $a0, output message 1 and syscall. So we have print printing the output message 1. After printing the output message 1, now we need to start another loop, and as well as since we are going to start another loop, again we need a loop variable t0, but t0 has already been changed. It has now gone up to 12, so we need to reinitialize it to start. Our loop variable should start with 0, so that is initializing the loop variable. That is our loop variable for the second loop. This is our loop variable for the second loop. We are using the same register. There's no problem with that one. And as well as we already have S0, which is the starting address of the array. So we don't need, we have not changed anything with S0. So we don't need that one. But S0 value should be again copied to S1, because you know S1 has already been changed. It is now pointing here. So you must bring it back to the beginning of the loop. So what we are going to do, we are going to just copy the value at dollar $s1, dollar $s0. $s0 is still containing the beginning of the loop value, so dollar $0. So that is we have done our loop variable, and we have got our starting address. So we are copying the starting address. So now we can start the loop again. So now this loop is finding some numbers, the numbers that are for loop. So I'm just giving the loop level finding for loop. That means it is going to find some numbers that are divisible by both 5 and 7. So again, branch greater equal. If t0 is less than 12, will continue. But if it is greater than 12, will go out of the finding for loop. So that is exit finding for loop. We need to do one more thing actually. Here we need to declare our sum register, because whenever a number will go through in the array, we'll actually iterate through each element of the array using this loop, finding for loop. This loop will actually iterate through all the elements of our array, and every element in each iteration will check whether the number is divisible by 5 and 7. If it is divisible by 5 and 7, we'll display that number, as well as we'll add that number to a sum register. So we need a sum register. We can declare our sum register li dollar t1. We can declare our sum register as t1. So t1 is our also initialized to 0. That's our sum register. Sum register to keep track of your sum, which are the numbers divisible by 5 and 7. So we'll exit the finding for loop. Sorry, for loop if the t0 value is greater or equal to 12, but if t0 value is less than 12, then definitely we'll continue the loop. So t0 is initially 0, so it's definitely less than 12. So now we are going to go to the inside the for loop. So we are going inside the for loop. Inside the for loop, what we need to do, first thing first, we need to load a number from the array. So load word, which register you want to load. Register number T2, you can use T2, and from which memory location that is pointed by S1. So T2 will get the first element of the array, which is 10. Now we need to check whether this value 10 is it divisible by 5 and 7. So what we can do, if it is divisible by 5 and 7, then we'll print that value, is not it? So print um, print um, number, print number. That's our but if it is not, then we need another level. If it is divisible by 5 and 7, we'll jump to the print number. But if it is divisible by 5 and 7, we'll jump to print number. But if it is not divisible by 5 and 7, then we have to jump to the end of finding for loop. End of, not, it's the exit of finding for loop. This is end of, or end task. End task, you can say end task of finding for loop, of finding loop, where we'll increment our loop variable and all those things. So first thing first, what we need to do, we need to check, whether T2 is divisible by 5. If it is not divisible by 5, then we'll jump here. We'll not print the number. But if it is divisible by 5, then we'll check another one. So first divide the number. So in order to divide the number, you need to use div instruction. Sorry, div instruction, and result should be stored in, say for example, P3, but we are not actually interested about the question. We are just interested about the remainder. So we can use div instruction with dollar $T2, dollar $T2, comma by 5, is not it? I'm not sure whether it will take one. Yeah. Usually with 2 argument, you cannot T3. I'm keeping it the third argument. So T2 will be divisible by 5, and the question will be stored in T3. Though we are not at all interested about the question, move from low or high. Move from high because we are interested about the question. So question should be stored in T3. So remainder will be stored in T3. So at the first division instruction, T2 is the first array element divided by 5, and the question will be stored in T3. But we overwrite the question by the remainder because we are more interested about the remainder, whether the remainder is equal to 0 or not. If remainder is equal to 0, that means the T2 is divisible by 5. Try to understand, a number is divisible by 5 if you get the remainder equal to 0. So if, for example, number 10, if you divide it by 5, question is 2, but that does not tell actually whether it is divisible by 5 or not. But if you get the remainder equal to 0, that will tell that it is divisible by 5. So number 10 is divisible by 5 because we will get the remainder equal to 0. So if we need to check our high register, because high register always contain the remainder in case of division. So we have done the division. T3 will initially contain the question, but we are not at all interested about the question. So move from high, we got the remainder, we store it in again in T3. So T3 is containing the remainder. Now we have to check whether T3 is branch equal. So we are not interested about equality. We are just interested about not equal, dollar T3, comma dollar 0. If it is not equal to 0, not equal to 0, then we should come to the end of finding. That means it is not divisible by 5. And if it is not divisible by 5, we are not going to print the value. But if it is divisible by 5, then T3 will be equal to 0. In that case, we need to again check whether it is divisible by 7 or not. So again, you have to do the div instruction, div, and again we can use the T3 comma, but the value is in T2. The number that we have got that is in T2 should be divisible by 7 as well. So T2, which is the first array element, if it is divisible by 7, then T3 will contain the quotient, but we are not at all interested about the quotient. We are interested about move from high, that will store the T3. Again, the remainder. Now again, you have to check the remainder is equal to equal to 0 or not. If it is equal to 0, then we'll print the number. But if it is not equal to 0, then we'll jump to the end task finding loop. So we'll check again, branch not equal, dollar $T3 comma dollar 0. If it is not equal to 0, that means we are not going to print the number. Rather, we'll jump to the end of finding loop. That's finding loop. We'll jump there without printing the number. But here, if we both the condition becomes true, because there is an and between them. So if this is true, and this is true in both cases. If both cases are true, then we'll come here. But if any one of them is false, then it will go end of task of finding loop, and will not print the number, will not add anything to our sum register. But if both of them is true, actually we don't need this level. I am leaving this level, I'm removing this level, and we need to print our number. Now, in order to print the number, you know, li dollar b0 printing an integer number is 1, and we need to. So this is basically reading an element from the array, and now we are printing. We are printing the number that is divisible by 5 and 7. You can see that every time we are checking the value of T2, whether it is divisible by 5. If it is divisible by 5, the remainder should be equal to 0 that we have got in T3. If remainder equal to 0, we'll continue. But if it is not 0, we don't need to continue. We don't need to check. We can come directly here and prepare the end task of finding loop. But if it is 0, then we'll again come and check by dividing the T2 by 7, and we check the remainder. If remainder equal to 0, we'll continue here. But if its remainder is not 0, then we'll come here and do the remaining task of the finding loop. So here we are printing the number that is divisible by 5 and 7. So the number interrupt number is 1, but the value that we want to print should be in A0. So add, but our number is in T2, so it should be moved to A0 comma dollar $T2 comma dollar 0. So after that we will call syscall, and after printing the first number, we need to also print our space. We need to print our space. So li dollar $b0 comma printing a space. It's a string, so interrupt number 4, and then add dollar $a0 comma space, and then syscall. So printing the space, printing the space, and then once we have done everything, we should automatically come to the end task of finding loop. But if whenever a number is not divisible by either 5 or 7, it will directly come here. It will not do any one of these tasks. So try to understand this. This is the checking part where we are checking whether the number T2 is divisible by 5 as well as divisible by 7. If both are true, then we'll print this. But if any one of them is false, then we'll directly come here and increment our loop variable. So add I dollar $t0 comma dollar $t0 comma 1, and you can check. um, we need to also update our value of S1, because every time we are going to read a new element from the array, so the first element we have read, in the next iteration we should read the second number and check whether the second number is both divisible by 5 and 7. So we need to update our S1. In order to update our S1, first we need to calculate our displacement. How to calculate our displacement? We can use now T3 or T2. Both of these registers value are no longer required for us, so we can use T3 comma dollar T0 comma 4. So the current value of T0 index value must be multiplied by 4. Result can be stored in T3, and then we need the new value of S1, dollar S1 comma dollar S0. As usual, S0 will remain as it is. That's your base address. Base address should remain as it is, but base address should be added with the displacement so that you can get a new value of S1. So your displacement is T in the register T3. So, and then we can jump to the beginning of the for loop. So jump to the beginning of the for loop means finding for loop. This is the loop actually which is finding the numbers that are divisible by both 5 and 7. So this loop actually find out our the numbers, and it will print all the values that are divisible by 5 and 7. So I'm just stopping here and call v0 comma 10 and syscall and check whether we are getting the correct result or not. So first I'm saving it. Try to understand. We have done both the two loop. One thing we have not done actually is after printing the number, after printing the space, we should also add the number to our sum register. So add the number to the sum register. You know that here we're checking whether the number T2 is divisible by both 5 and 7. Then we are printing the number, we print the space, but we have not added the number to our sum register. By the way, which one is our sum register? Sum register is T1, so we can add the value of T2 in T1. Dollar T1 comma dollar T1 comma dollar T2. So T2, sorry, T2 should be always added with T1 because T1 is our sum register. Uh, so adding the number to the sum register. So after the loop we finish, after we finish the loop, we can print the sum value, but we'll do that later on. First check whether our program is giving any trouble or not. Space, I think it's not actually add instruction, that is LA instruction to get the starting address of the space. So save, no error message. So we are entering the number 10, 14, 20, 10, 14, 20, 28, 30, 35, 28, 30, 35, 40, 42, 45, 40, 42, 45, and I can two numbers, three more numbers, 49, 50, 70, 49, 50, 70. Numbers that are divisible by both 5 and 7 are 35 and 70. Yes, these are the two numbers that are actually divisible by 5 and 70. You can see the result we have got. So basically, we have done our job, but only thing that the number that we have added in T1 after the exit finding for loop, before we exit from the whole program, you can print the output message 2, and you can print the value of T1. That will finish your program. But I just want to leave it for you. I don't want to do that one. So you can see that this is our program. I'm just showing you step by step, 21 lines, first 21 lines. This is the first 21 lines, sorry, 20 lines from the beginning, first 20 lines. Then we are going to show you next 20 lines. This is next 20 lines. Then this is your I think almost last 20 lines. This is the third 20 lines. And that is the end of your program. But this is a place where you can add some instruction to print the output message 2 and print the value of T1, which is the sum of all the numbers that are divisible by 5 and 7. So that's the end of our class, end of our problem solving. Okay, so we stop sharing.